With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, our question is a uniform row of length L lies on a table. If the coefficient of friction is mu, then the maximum length L1 of the part of this row, which can be overhang from the table, from the edge of the table without sliding edge. Okay, so without sliding means the rope should not slide over the table. So let's say this is the rope of which some part is lying on the table and some part is hanging from the table. Okay. Hi everyone, our question is a uniform rope of length L lies on a table. If the coefficient of friction is mu, then the maximum length L1 of the part of this rope which can overhang from the table without sliding down is. Okay, so we have a rope, say this is the table on which a rope is lying, such that a part of the rope is lying on the table and the length L1 of this rope is hanging from the table. Say this length is L1, and since the given total length of the rope is L, so the part of the rope that is lying on the table will be L minus L1. This much length of the rope will be lying on the table. Okay, so we have to find actually the part of the length L1 that is hanging down without sliding. What can be the maximum possible value of L1? Okay, so in this case, the weight of the hanging part of the rope. So let us say lambda is equal to linear mass density of the rope. Linear mass density of rope. I mean to say lambda is mass per unit length, or we can say mass of the unit length of the rope is lambda. Okay, so we can now say that weight of the hanging part, weight of hanging part of the rope is equal to lambda times L1. This is the mass of the hanging part, and if we multiply it through Z, so it will be the weight of the hanging part. Okay, and the weight of the part lying on the table, weight of part lying on the table, it should be equal to lambda times what is the length of the rope that is lying on the table. It is total length minus hanging length. So this much mass, and if we multiply it to Z, it will be weight of the part which is lying on the table. Okay, so for not slipping, for not sliding down, but actually there must be, so the friction force that is acting between table and the rope will should be equal to the weight of the hanging part, which is equal to lambda times L1 into Z. These two forces should be equal for not sliding down. Okay, so we can write it as for not sliding, the two forces, that is the weight of the hanging part and the friction acting between table and the part of the rope lying on the table, should be equal. So we can say lambda L1 G should be equal to what could be the friction acting between table and the rope lying on the table. That will be equal to friction coefficient times the normal reaction. Okay, and what is the normal reaction? That will be equal to weight of the part of the rope lying on the table, so it will be lambda times L minus L1 into G. So now we have to solve this equation simply. by solving we can obtain the final relation for L1. So here we can cancel g both sides, we can cancel lambda both sides. So the final expression we are obtaining is L1 is equal to mu times L minus L1. Okay, we are getting L1 is equal to mu times L minus. Now we can simply obtain the value of L1. Just do one thing, L1 plus mu times L1 will be equal to mu L. This will be mu times L equal to mu times L. Okay, so if we take out L1 common, so L1 into 1 plus mu is equal to mu L. This implies L1 will be equal to what? L1 will be equal to mu L upon 1 plus mu. This is the maximum part of the row that can be hanging without sliding down. Okay, so now which of the given option is correct? L1 is coming to be mu L upon 1 plus mu. So the given option is C is the correct relation for L1. Okay, so I hope you are clearly able to understand. Thank you for watching.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.